Hello and welcome to Yeyu Lab. Google launched Gemini 2.0 with the preview model Gemini 2.0 Flash Experimental, and you must have learned about it from the videos and articles in the internet. This model has greatly exceeded the performance of its predecessor, Gemini 1.5 Pro, in all the benchmarks, and is free for everybody to use with some limitations in Google AI Studio. If you have experienced with it or seen videos about the features in the new version of the Google AI Studio, you must be impressed by its capabilities and efficiency in handling complex reasoning tasks, generating reliable code and function calls with a massive 1 million token context window. And its faster speed and lower latency is also outperformed to the Gemini 1.5 Flash model. While these features are certainly impressive, they are becoming common expectations whenever a new model is released today. What truly sets Gemini 2.0 apart and has the potential to revolutionize the LLM landscape is its advanced multimodal capabilities. The model now can seamlessly process and understand the multiple input modalities, including text, images, and audio and video, and responds with text or audio in real-time streaming scenarios. The breakthrough makes the AI agents more human-like and more helpful for common users. In this video, I will be focusing on the multimodal features of Gemini 2.0 and walk you through the official demo app on Google AI Studio, as well as a code implementation on a native and self-hosted app to showcase how to build your own real-time chatbot with voice and video interaction by using Gemini 2.0 Multimodal Live API. The quickest way to experience the impressive multimodal capabilities of Gemini 2.0 is to use the demo app on Google AI Studio. If you have used it before, you will find that along with the new model release, the UI has been updated to demonstrate the new features, including the streaming real-time section for Multimodal Live with Gemini 2.0 and the starter app section that includes 3 pre-built apps with source code for further development. So let's click the stream real-time section to see what we have provided. So here it said study interacting in real time using text, voice, video, or screen sharing. There are 3 apps provided. Talk to Gemini, which is using the voice communication, showing Gemini that use your camera to share what you are looking at and get the real-time feedback, and also share your screen, and Gemini will answer about what you are working on. So now I will be using the Show Gemini app because it's including the voice interaction in the app of Talk to Gemini. And the camera interaction is basically the same of screen sharing in the video interaction perspective. The camera images are more unstructured and random and more interesting for sure. Hey, how are you today?
I am doing well, thanks for asking. How are you doing today?
I'm good. Can you help me identify what is this?
Sure, I can help with that. Could you please show me the object you want me to identify?
This one.
Okay, that appears to be a small white square object. Would you like me to try to narrow down what it could be?
Yeah, please guess what is this.
Okay, based on shape and color, it could be a charging case for wireless earbuds. Would you like me to guess again?
No, you are correct.
Great, I'm glad I could help. Is there anything else I can assist you with today?
The feature is so impressive, so you can try it out by yourself through the Google AI Studio link with your Google account because it's totally free at this moment. Now I will be trying to use the same Gemini Multimodal Live API to duplicate the same experience in a native and self-hosted app. Let's look at what is Multimodal Live API. There is a statement that this product of the feature is at experimental stage and it might have limited support. It looks like the API is not at the same page as a common generative API. But anyway, let's see its features. Here, the Multimodal Live API enables low latency two-way interactions that use text, audio, and video input with the audio and text output. So its ability including multimodality, low latency, real-time interaction, session memory, and support for function calling, code execution, and search as a tool. And you also need to note that the API is designed for server-to-server communication, which is mostly because of its protocol is not HTTP, but the WebSocket. So the HTTP client, like your browser, is not able to connect directly to this API. As a result of the recommended architecture, you need to implement an intermediate server to handle WebSocket connection with the API and then forward the message to a front end. When you search on the GitHub, you will find that Google has provided some source code for the Multimodal Live API demo. Unfortunately, the code is either too simple, like this, with only basic generation process, or too much tightly coupled with Google Cloud project infrastructure. That's why I decided to implement my own version of web app as beginning, which will be a simple chatbot but can be extended to a more complex voice and video interaction app easily for future web apps. Let's start with our implementation. The fundamental design of our app is based on the demo project of Multimodal Live API demo that provided by Google Generative AI team. For its usage, you can see from the README file that it asks users to connect with the access token and project ID, which comes from the Google Cloud project domain, where it's supposed to host the backend service. And then you can start the real-time interaction by text, voice, and video. The design is simple but intuitive, so I will be following that. And then when you look at this architecture, it provides a backend server designed by Python to handle the authentication and act as an intermediary between your front and the Gemini API, and a front-end server that provides the user interface and interacts with the backend via WebSockets. So I will also be following that besides the authentication part, which is only related to the Google project infrastructure. So in conclusion, our app will also be such stack. There will be two WebSocket connections, one for the client to the server and one for the server to the Gemini API. It's not that complex. Our first focus on this code walkthrough will be on the server side in Python, because it's the main difference from the official Google demos and it's key to activate the Multimodal Live API. So first, let's install the packages. Pipe install Google Gen AI. So you must make sure that you install the new version of the Google Gemini SDK by install Google Gen AI for the Live API. In the code, we need to import the necessary packages and load the API from Google AI Studio and define the model to Gemini 2.0 Flash EXP, and then define the client, which is initiated by the Gen AI client class, client method with the configurations. Here we use the V1 Alpha as the API version, and the client is the main interface to interact with the Gemini API for later use. And the next is the method of the core logic Gemini session handler. In this function, we will be handling the WebSocket connection with the client and then forward the messages to the Gemini API, then receive the response and forward back to the client. So all these communications are based on the WebSocket protocol. So that's why they are all async, which can be interrupted, reconnected, or restored. These are the key enabler of the real-time behavior. So we skip its details here, by looking at the server setting up part in the below code. Here, the main function. This is the main function of the server. We'll be running the WebSocket server on local host with the port 9080. And then for each connection, it will be calling the Gemini session handler function to handle the WebSocket data flow with the client, and using the async IO future method to keep the server running indefinitely. So now let's get back to see the details of this session handler. The first WebSocket message is always the config message, which is the setup message for the Gemini API. It can contain many parameters for the model, but in our case, we only need to use it to set the model generation modality, whether it's response with text or audio, which is set from the client side. The response modality can be audio or text. The config message will trigger the connection to the Gemini Multimodal API by the method client AIO live connect to the model with the configure as a session. So after the connection is established, that means the WebSocket with the Gemini Live API is ongoing with the session context. The server will be waiting for actual client data from your front end. So there are two main parts in the session handler to process. One is the sending to Gemini method, and the other is receive from Gemini method. The message from the client is handling here, which is a custom message format in a JSON object with the real-time input. This field contains the media data from the client web page, including the audio PCM data or image JPEG data, which comes from the camera capture. The server will be simply packing the data into Gemini API message format and send it to the Gemini Multimodal Live API by using the session send method. In the receive from Gemini function, the server will be listening and receiving the response from the Gemini API by using the session receive method, and then unpack the data into a customer message format and send it back to the client, which is processed here. Note that there are two types of response data need to be handled differently. One is the text data, and the other is audio data. The text response is a simple string, and the audio response is a base 64 encoded audio data. Which path will go is a decision from our config message. And because the real-time nature, the data are all streaming with trunks or called parts here, you have to make the receive and forwarding process keep running until the turn complete flag is being set. After the definition, the two methods are launched as background tasks, and then the async IO gather method is used to run them concurrently. That's all for the server side. Now let's look at the client side, which code is defined in the HTML file and in JavaScript language. So I will not go through the lines of code here, especially the layout and styling of this normal HTML content. And you can see the full code in my GitHub repository listed in the description, but I will be focusing on some key logic of the client side, which is mostly around the WebSocket connection and the message handling. So when you open this web app, it will now automatically connect to the WebSocket server on local port 9080 and then send the setup message to the server. The setup message is a JSON object with a setup field The field contains the generation config with a response modality as a list, and I set audio here to indicate that the response from the model should go through the voice data. And also I will change it to the later test to see how the performance of the real-time text response. I have tried list both in the list to have audio plus text response in one message, but it doesn't work at this moment with an initial error. So we can now only set it to either audio or text to do the test. The start audio input function manages the microphone access, capturing audio and send it to the backend via WebSocket. And the capture image function periodically capture the image from the webcam and also send it to backend via WebSocket. These are for the user input part. In the receive message function, the ingest audio trunk to play function will process the audio data sent back from Gemini model and sends to the audio stream to PCM processor worklet for playing back on the browser. And the similar process for the text output is handled in the display message function. These are the logic for the output part. So we know the input and output. These are two critical parts of the client, and because the model response format of audio is PCM format, we need to convert it to the audio format that browser can play, so that we use the PM processor worklet defined in the PCM process.js file to do the audio conversion. Now we can run the app. So to successfully run the app, you should run the both backend and front end. Let's run the server side as the backend first. Here we just simply run the Python file. So you will see the log running WebSocket server localhost 9080. So that means the WebSocket server has been successfully running. Now let's run the front end, which is a HTTP server. So let's move to another command line environment and run the Python command, python -m http.server. Make sure you are running this command under your project root folder. And then the serving HTTP on the open URL port 8000 is available now. Let's look at in our browser. Hey, how are you today?
I'm doing well, thank you for asking. How are you doing today?
I'm very good. So what is this?
It appears you're holding a small white square-shaped object. Can you tell me more about it, or what you'd like to know about it?
Could you have a guess? What is this?
Is there something else you'd like to tell me or ask me about?
No, just this one. Can you guess what is this?
Okay. Is there anything specific you'd like to say or ask about this one? You're asking what the white square object is, correct? Unfortunately, I cannot know exactly what it is, but it looks like it could be a charging case for wireless earbuds. Would you like to tell me what it is?
Yes, you are correct.
Okay, so I was right. It is a charging case for wireless earbuds. Is there anything else I can help you with?
Yeah, the app is successfully running as I expected. If you want the output of the model convert from voice to text, you can simply change in the HTML file the response modality, change from audio to text, save, and rerun the HTTP server, and then have another try. Hey, do you know what is this? No, I mean what this small white object is. Yeah, it looks good. And can you describe the image? In conclusion, we can now duplicate the real-time experience for the Multimodal Live API in a native and self-hosted app. This is a great starting point for you to build your own real-time app. For example, you can add screen sharing or function calling to the app to make it more practical in both life and work. You can also add some function like translation, transcripting, to help the user to more understand what the model is talking about. Most important is the usage of API is free.